All right, well, hello. My name is Miss Quillen, and I am an eighth grade, well, currently an eighth grade science teacher. So I chose to teach a standard from my current eighth grade science curriculum. So typically what I do in my class is I give a note-taking guide. So for my more advanced students, I would give them kind of more of a blank note-taking guide. And for those students who need a little bit more assistance, those notes might be more along the lines of fill in the blank, just a little bit extra for them. So for this lesson, I'll go ahead and present. And I would like to preface saying that there's usually a lot of dialogue in my classroom. So I will do the best I can with not having an audience. So the lesson for today is on stars. So this is the very first day of my Unit 7, the universe. And so our standard here is to be able to describe and classify specific physical properties of stars. So apparent magnitude or brightness, the temperature, how that relates to color, the size and luminosity of the star. And so what I want you guys to do by the end of the lesson is to be able to describe a star. We want you to be able to differentiate between what apparent magnitude and absolute brightness are. Those are related, and we'll discuss that. And then we also want you to be able to explain, how do scientists study stars at all? So we'll touch on that a bit today and kind of introduce you to it, and we'll dive deeper into that towards the end of the unit. All right. So to give us an introduction, here are a few stars that exist in our universe. And so the sun is obviously one of them. That's the most important one to us. But we can see that the stars, or our sun, is actually quite small in comparison to these other stars. And you also might see that there's a variety in color, size, how bright they look to us. And so that leads us to the question is, these are all very different. So what makes them a star? What is a star? What are your thoughts as to what a star is? So a star is a giant ball of gas. It undergoes nuclear fusion, and that causes it to produce its own light. And so you should recall this from last unit when we learned about the sun, right? So a sun, it is a giant ball of gas. It undergoes nuclear fusion. That's that process where hydrogen atoms are fusing into helium to form those heavier elements. And this process creates a ton of heat and light and energy, and that's why we can survive on our planet. And so most stars are made of two ingredients. Does anyone remember? I mean, I literally just said them. The ingredients in a star, it's hydrogen and it's helium, okay? Most stars, when they're in the main sequence, and we'll learn all about the main sequence stars later on in the unit, they have hydrogen and helium as their primary ingredients. So how is this different from planets? Does anyone remember from last unit when we learned about Jupiter? What is Jupiter mostly made of? So hopefully you remember Jupiter is also made of hydrogen and helium. So why is our sun a star, but Jupiter is just a planet? What's the difference between those two? Can anyone tell me what they think the difference is between Jupiter and the sun? So hopefully they were able to tell me that a star, it produces its own light due to that chemical reaction we talked about, that fusion. Planets, they don't have enough mass for nuclear fusion to happen, and so it doesn't. So in planets, they only have light because of a star like Jupiter. So hopefully now you understand the difference between those two. They can be very similar. Jupiter, if it were more massive, it had more mass, it would have been a star. Just didn't quite get there. That leads us to the next topic. Why do stars look the way that they do? When we look up at the night sky or we look at this image, we see different varieties of brightness, color. Why do they look that way? And does anyone recognize the figure that's in the sky? So the figure in the sky is actually what we call an asterism. It's not a constellation, but it forms a picture in the sky that's not a recognizable constellation. If you guys notice this right here, this is our Big Dipper. And we can see there are different colors and brightnesses of these stars. Why do they look that way? So the brightness of a star, it depends on its size. So how big is the star? And also depends on the temperature of that star. Now, how bright the star appears to us here on Earth, that depends on the distance that star is from Earth and also how bright that star truly is. Okay, so there are a couple of factors that go into that. So that leads us to the first real term that you need to know aside from what a star is, right? This is apparent brightness. And this is also known as apparent magnitude. So those two terms, they mean the exact same thing. So this is the brightness of a star as seen from good old planet Earth. So as we're standing on our Earth, looking up at the stars, how bright do they appear to us? So we have our sun, for example, right? Why does the sun look so bright to us? Well, the sun's the brightest star because it's the closest. It's super close to us, and so it has a very, very high apparent magnitude. Here is a great example of apparent magnitude. So let's say we're looking up at the sky and we see two stars. They look to be the same size, the same color, same brightness. So that's what it looks like. That's what you see, equally bright. In reality, star A is way bigger and brighter, but it's just much farther away. Whereas star B, it's smaller, but it's a lot closer. And so these two stars, they have the same apparent magnitude, but are they the same type of star? Are they as equally bright? No. And so apparent magnitude is useful, but it's not perfect because it doesn't tell us the true brightness of a star. And that leads us to our next term, which is absolute brightness. This is also known as a star's luminosity. So this is the true brightness of a star. This is how bright the star would be from a set or standard distance from Earth. And so how do scientists figure the true brightness of a star? Well, they figure out how does it look from Earth, their apparent brightness, and then they have to figure out how far away, what's the distance of that star. That's how they can figure out the luminosity of the star. So here are some stars, and these are at a set distance. Now this is their actual distance from Earth, but this picture is showing that if all these stars were the exact same distance from Earth, this is how bright they would be. And we can see we have a variety of brightnesses, of colors. Which one do you think is the most bright here? And you notice it's the one in the top right-hand corner. And if you look at the numbers, you notice that it has the highest value of all these other stars as well. Okay, so this is the luminosity or absolute brightness of a star. So how do we study stars, right? We're talking about all these things that we know about stars. How the heck do scientists study them in the first place? What are some tools that you can think of that scientists use to study the stars? So we'll get to those in a sec. Scientists use those tools to gather evidence, right? And they use this evidence to make mathematical models. They use this evidence to create computer simulations. And the whole goal is to build our understanding of the universe. That's the goal of science, to build our understanding of the world around us. And so astronomers, those are the scientists who study the stars, they gather evidence using those tools that hopefully you're thinking of. And so probably the most important tool is the telescope. And this image is of the Hubble Space Telescope, and we'll learn more about that towards the end of the unit when we look into the technologies in space. This is an image taken from the Hubble telescope, and the Hubble is just one of many, many, many different telescopes that are out there. And so this is a really cool image because it shows two shots. They're the same shot, but they're shown in different wavelengths of light. So the one on the left shows the visible light spectrum, and the one on the right shows infrared. So remember, visible light in the EM spectrum, that's the light that we can see with our own eyes. Infrared we can't see, but we have telescopes that can interpret that for us to put it in the visible wavelengths. Now this other picture, it's not really as impressive and cool looking, but in my mind it's even cooler because you see each of those little smudges in the image that are different colors and different sizes. Each one of those smudges is a galaxy, just like our galaxy, the Milky Way. And it's pretty wild to think that there are that many galaxies just in this one picture. Could you imagine how many galaxies there are in the universe? And we'll get some guesses on that in a sec. So scientists also use a tool called the spectroscope. And so the spectroscope is used to break that light into colors, the light coming from the stars. It breaks that light into colors to produce an image of the resulting spectrum. That allows scientists to see what elements are found in that star, and they can figure out the composition of the star this way. So here's an image from spectroscopes of different stars. So we have like a list of stars on the left-hand side, and notice that each one of these are not identical, and you see little dashes of dark area that's missing. So the pieces that are missing, this tells the scientists exactly what elements are found in that star based off of what's missing. So it's pretty crazy that they can figure this out. Could you imagine being the person who's like, hey, look, this element, it corresponds to this color of the electromagnetic spectrum? Like, it's pretty awesome. So we look up at the sky. I absolutely wish we could actually see the sky this way. But unfortunately, good old light pollution doesn't let this happen anymore. But how many stars are out there? When we look up at the sky, there are only around 9,000 that we can actually see with the naked eye. Remember, naked eye is just without the use of a telescope. Only about 9,000. So how many are truly out there? What do you guess? What do you think? Scientists have some estimates. So our galaxy, remember, our galaxy is the Milky Way. Just in our galaxy, how many stars do you think there are? It's 100 billion. Was that what you were guessing? Probably not. Now, how many galaxies do you think? So just in our galaxy, we have 100 billion estimated stars. How many galaxies are in the universe? There are estimated 2 trillion galaxies in the universe. So using those estimates, the universe has about 200 billion trillion stars. It's a lot of stars. So that's where I would, wrap up the direct instruction. That was a little powered through that. Normally there would be a lot more dialogue with the students. And so at this point, they're finished with their notes and the information that I want them to have for the day. And I would lead them into this crossword puzzle. So I think I like crossword puzzles as one of the activities of them working together to try to absorb the knowledge, because it's kind of fun for them. And it gets them reading and looking back at their notes. So I would have them work with their table partner to solve the crossword puzzle. If these were more advanced students, then I would ask them not to use their notes at all and try to do it from memory and see how much they could complete that way. And if they were students who needed a little bit more help, I would allow them to use their notes as a resource the whole time that they're working on it. I think it's obviously important for them to just be referencing their notes. The more times they're reading this stuff, the more it's going to sink in. So after they were finished with the crossword, then we would obviously go over it together. And then that would just lead to the exit ticket, which was our final takeaway. Just a short summary of what we've learned. If they were the more advanced few students, I would ask them to just do this based off of what they've learned. If they were students who needed a little bit more help, a little bit of differentiation, I would give them, or I did give them, words that I wanted them to include in their summary to make sure they touched on that. So that was my short lesson. Hopefully you enjoyed it. And I look forward to getting to know you. Thanks.